everyone. It's a pleasure to welcome you all to the fourth edition of Smarter Conversations, a thought leadership journey by AMNS India, proudly presented by Optigal. This series is about more than just ideas, it's about reimagining the way we build, design, and shape the future. Smarter Conversations is where bold insights meet practical wisdom, where knowledge transforms into inspiration for the entire engineering and construction ecosystem. Today's session, Beyond the Factory Floor, Tendering, Estimation, and Civil Strategy, takes us into the unseen and critical foundations that drive industrial success. Because behind every landmark project lies vision, precision, and strategy, the pillars that turn ambition into achievement. Today, we are honored to be joined by Mr. Siddhant Shah, Deputy Director at MR Warerkar and Associates Pvt. Limited. Mr. Shah embodies the spirit of next generation leadership in industrial and warehouse architecture. An alumnus of University of Bristol, he is recognized among the APSD Young Icons 2024 and Harappa Upgrads 40 under 40 high impact managers. He has led the design and execution of the transformative facilities for brands we all know: Maruti, Pepsi, Britannia, Dixon, Supreme, Relaxo, and ITC. Beyond the buildings and numbers, what defines his work is the ability to blend strategic thinking with on-ground execution, demonstrating how tendering, estimation, and civil strategy can truly power innovation and impact. It is privileged to have him with us today. Over to you, Mr. Shah.
Hello, everyone. So firstly, thank you so much for having me and welcome to the fourth webinar organized by AMNS in collaboration with Optical. Firstly, thank you to AMNS for having me and allowing me to speak on the project. Just as a by the by, one of the first projects that I did end up working on while I was in the UK was for ArcelorMittal. So it's quite a full circle moment for me to be representing the company and giving this webinar. And thank you to all of you all for joining on a Friday afternoon. It's been raining in Delhi and around the country, so it's not been the best. I guess it makes it better for you guys to attend webinars. So thank you so much for joining. And I'll start to Smarter Conversations by Optical, the fourth session of the sort of webinar series that we're having. And the topic that I will be covering today is Beyond the Factory Floor, looking into tendering, estimation, and civil strategy. So for any of you who have any questions during my webinar, I'd request you to please write your questions down as the webinar progresses. I'll take them up towards the end of the session. There is an option to send some questions. And we also have a few polls going on through presentation. So I'd request all of you to please participate in the polls as well. It's a good thought exercise and it's a good way to gauge how people are thinking and the sort of problems that do exist within the industry. Yeah, so this is Beyond the Factory Floor by MR Warerkar. So before I start, I'll just take a quick minute to talk about Optical, the product for whom we saw the briefing video. So Optical is a pre-painted galvanized iron sheet that has been designed specifically for the Indian market. It's being used around Europe, but now it's been launched for India. So as a country, because we're a peninsula, it's a coastal country, we have a lot of issues with corrosion, we have a lot of issues with rainfall, and a bunch of other problems. So the reason why Optical is a great product, and it's something that we at MR Warerkar have been exploring and using as well, is that it's a zinc, aluminum, and magnesium based alloy, which is the first of its kind. And because it is zinc, aluminum, and magnesium as a hot dip sort of galvanized product, because of the testing that we have seen and the results that we have seen, it performs 2 to 3 times better than a traditional hot dip galvanized coating. And furthermore, by means of using magnesium, it's actually preventing delamination, cuts and scratches on edges, which is another major problem that we see, because due to what I'd like to call edge creep that takes place at the edge of the sheet, it does get susceptible to becoming the fault line for a lot of problems, and you can have rainfall egress and a bunch of other problems that can happen, which is something that is taken care of by Optical. And also because it is zinc, aluminum, and magnesium, It's free from a lot of heavy metals. So it is a lot more sustainable, and it's also lighter, which helps the overall structure and helps in terms of design. I think it's around 4 to 5% lighter than traditional sheets. So that is also something that's quite beneficial. So from a process perspective, I think they call it the ZAM technology, or the zinc, aluminum, and magnesium technology. All three layers are coated through hot dip galvanization, and this creates a compact oxide layer, and this oxide layer acts as a barrier that slows down corrosion, which is something that hasn't been seen across the industry. I think there's a patent on this as well. Then one more thing that I have really liked about this product is Optical. They're able to give a variety of products depending on your use case. So say, for instance, you only need to make a garage system, or if it's a house, or if it's not something that you envisage being used for, maybe 15, 20, 25 years, they've got a core and a pure sheet that has a warranty of 7 to 10 years. And for heavier use cases, for industrial buildings, for warehouses, for regions that are close to the coast, they have Optical Prime and Optical Pinnacle. Optical Pinnacle, these are 15 to 25 years warranty they come with, which is again a sort of best in class in terms of what roof sheets are giving these days. And lastly, from an application and performance basis, the variety they have in their use case is astounding. You can use it for cladding, you can use it for roof profiles, for sandwich panels, for facade systems, for whatever you so choose. So from that perspective, I mean, it is a very, very good product. And the reason I feel like large companies like Kirby and Pennar have been adopting this product, and I see it being used more and more in the future. So before we enter the technicals, I'd like to give a brief on who we are, what we do as a company, and who I am and what I do. So my name is Siddhant Shah. I am the Deputy Director at Warerkar Associates. As a firm, we specialize in the design of factories and warehouses. We worked in 13 countries across 3 continents, and we've completed close to 2,000 greenfield factories and warehouses, expansions notwithstanding, and have designed close to 22 million square feet. And for us, I often like to say that you cannot survive a day in India without using a product that's come out of a factory that we have made. So our expanse in the sort of industry is so much that whether it's the toothbrush you use, the food you eat, the flight you take, no matter what, or the car or vehicle that you're using to travel, you can't survive a day in India without using a product that's come out of a factory that we have designed. Some of our major clients include PepsiCo, Britannia, Supreme Industries, Relaxo, ITC, Dixon, as a bunch of clients. We've had the pleasure of doing 2,000 greenfield projects within like an 80 to 82% client retention rates. We've had the pleasure of working with some of the best and biggest companies in the country, as well as abroad. As a firm, we have worked across 13 countries and 3 continents. We've just broken ground in South Africa, which is our 13th country. In India, we've worked in every state and union territory pretty much. In the Northeast, we've gone as far as Assam and Meghalaya. But other than that, we've worked in pretty much every state in the country. These are some of the clients that we have worked with and continue to work with. And I'm sure you'll recognize a lot of these logos, and we hope to continue working on this. We're a 60-year-old company. We hope to continue for at least 60 more. And this is a glimpse of the sort of variety of projects that we are doing. Just to give you an idea, I hope my cursor is visible. So the first project that you see, it's for a company that makes medicated animal feed. And the reason I've chosen all of these projects, I'll go over a feature for each of them, is because all of them had a specific peculiarity that we had to deal with that was not something that is cookie cutter, that is not something that you have to deal with on a day-to-day basis. And we had to use our ingenuity in civil engineering, in design, in strategy, in tendering, or a combination of all of these to try and, come through with what we can do. The first product was for a medicated animal feed facility. This, first of its kind, never made in India, goes from 45 meters up to -5 below the ground. The machine is not manufactured in India. The drawings came in either Dutch or Chinese, and the sort of wind loads and other loads that had to be dealt with, it required a very high level of precision, engineering, and scheduling. The next project that you see was made in a country not familiar to ours. So all our tendering strategies and everything else sort of went out the window. We had to go to the local country and sort of figure things out for ourselves. The third project that you see is kitchen for the food you eat in flights. Here, the owner required, firstly, it was a 2-acre plot that required 3 acres of construction. So we had to be very, very frugal with how we designed. And also, this is the largest construction without using cement and steel. It's 100% drywall and steel, sorry, without using cement. It's 100% drywall and steel based structure. We have the Limca record for the largest drywall construction in India. And like, as you can see, there's a picture in the middle which doesn't look like a factory at all. This is a project we did in Bhutan, wherein we were only permitted to use traditional Bhutanese architecture in line with what the king wants. So each of these projects shows a glimpse of what we have to do as engineers on a day-to-day basis and how we have to use our design ingenuity to actually try and solve problems. And this sort of leads into the project wherein how do you actually think beyond the factory floor to impact what is going to happen within the factory floor, and how do you sort of cohesively tie everything together. So for us, one of the issues that we see with a lot of clients is, and with people in general as perception, when you tell people you design factories and warehouses for a living, the first response is उसमें क्या होता है, आप डब्बा ही तो बना रहे हो, मतलब है तो डब्बा ही. Very often what I do see is people refer to the factory itself as a box, and what you are making is a big and shiny box with no design ingenuity required. And this is from, I mean, not just from lay people. I've had a client actually come up to us and say कि अगर बारिश और धूल नहीं होती तो मैं खुले में मैन्युफैक्चरिंग करता, मुझे डब्बा बनाने की जरूरत नहीं. I mean, I won't name the client, but this is again the sort of perception that you have to deal with. However, as you can see from the slides that I've shown you here, as well as just one single premises that I have made over here, this couldn't be farther from the truth. So just within this facility, I feel that we have, I think, given 4 different types of factories over here. If my cursor is visible, over here we've got a dairy manufacturing unit which had tanks, silos, a multi-storage structure. This was a PB building made with a curved roof. These are more traditional PB buildings. This is a concrete structure. We've got just silos that need to be housed over here. So within the same facility for the same client, we've had to make 4 to 5 different kinds of just dabbe. And because of this, I'd like to say that this perception is as far from the truth as can be. Furthermore, I feel we now live in a time where designing the factory and warehouse, it's part of the machine. Additionally, we have a lot of pressure to always keep working against the clock. I mean, the most common request that comes to us is हमें आपके पास 2 महीने पहले आ जाना चाहिए था, लेकिन हम लेट हो गए मशीन ऑर्डरिंग में, तो अब इसलिए आपके पास आए हैं, तो 2 महीने कम होंगे आपके पास पूरा डिजाइन करने में. So you always are working on a fast track basis. You're working with high quality. The project has to be cost sensitive. The project has to be compliance heavy. All these things sort of lead into each other. And under all this pressure of working against the clock, a key way to shape the long-term success of a building floor, in my opinion, is through estimation and civil decisions. Proper civil strategy, in my opinion, can help with cost, it can help with compliance, it can help with not just the present, but the future, and it can help with using sustainable design practices. And lastly, a sort of gripe that I have as an industrial design company is clients only think about their factory floor. And as developers, there are a lot of developers on this call. What does tend to happen is when people are pitching to you, they only talk about the factory floor. They will only talk about the box and they will only give you the cost of that box. However, that shed is only half the battle won. Roads, utilities, drainage, worker facilities, these things contribute the balance 50% of the project, and they make or break the success and failure of the project. Now, I keep coming back to this particular project, and I will keep coming back to this particular project. This is one of the case studies that I go over as well. But in this one singular project, through means of smart designing, civil planning, and ingenuity in tendering and a bunch of other things, we were able to save our client something to the tune of 135 crore rupees. And this is something, I'm just going to try and discuss to the best of my abilities the sort of strategies that we did use and how you can, as architects, civil engineers, developers, leaders of the industry, use similar strategies to come up with something that can work for you as well. So as a country, India, as you know, has seen unprecedented growth in both manufacturing and warehousing. I mean, the way we're running, as we have seen these upward trends in manufacturing and warehousing, we've had increased spending power as a country. We've had more access to spaces owing to a better road network, rail network, and flight network. We've had schemes like PLI and Make in India. We've had increased consumer demand cause a boom in the sort of warehousing industry. And this has caused India to be we are projected to be the third largest manufacturing hub by 2030. So with all this going on, keeping up with the demand while mitigating challenges that are both process related as well as so uniquely Indian is, in my opinion, the crux to how a project should be planned. There can be delays in land acquisition. There can be delays in statutory approvals, wherein, I'm sure, having dealt with the authority, there are umpteen number of reasons why projects get delayed. There are environmental clearances. India, there's a festival every day, and that festival causes someone or the other to take a leave every day. I mean, we're in the middle of Ganesh Chaturthi right now. The presentation that I was doing got delayed by 2 days because Maharashtra wasn't available due to Ganesh Chaturthi. There are monsoon delays, there are environmental delays, and all of these challenges are very, very uniquely Indian. And while doing this and keeping in line with how we are aspiring to be the third largest manufacturing hub by 2030, attracting global investment and trying to become a global leader, a contextualized civil strategy is a must to help mitigate all the issues that we face. So this is the typical design life cycle of a project that we use at MR Warerkar to sort of ease our understanding of how a project needs to be done. But if I were to break it down quickly from a promoter's perspective or from a layman's perspective, the flow would be you acquire land, you do the master planning, you do the design and simultaneously get your project's approvals, you do the tendering and the procurement, then you go in for civil works, you construct the factory, and you go into operations. And then once your demand is fulfilled and then there is more demand increasing, you go in for project expansion. And after your closeout, it sort of loops back into the start, and this process is repeated again. And in my opinion, you have to work, and as you can see in this flow chart, you have to work on multiple fronts at the same time to ensure that your project is delivered. So, I mean, once your preliminary DBR is approved, you're simultaneously working on statutory approvals, you're working on DBRs, detailed designing, tender documentation. All these things sort of collate in at the same time. So because you're working with multiple fronts and multiple stakeholders at the same time, things become very chaotic. And if we get the first 4 stages right, if we get the master planning, the design and approval, tendering, procurement, and land acquisition, if we get this right, the factory construction, the operations, and the expansion become a breeze. And for your client, it becomes very easy to actually use their facility and then expand without having to disrupt their existing facilities. So very quickly, I thought I would like to do a quick poll, and I'd request the team to actually put the poll on. So in your opinion, what is the single biggest challenge that you face during tendering? I mean, is it cost accuracy? Is it vendor reliability? Is it scope clarity? Or is it time constraints? I'd request the team to display the results. I think that's a minute or so done. Do you reckon we can share the results of the poll? I think what I can see is it's actually quite tight. I think 31% of people struggle with scope clarity, 29% with cost accuracy, 24% with vendor reliability, and 17% with time constraints. So I think it's pretty neck and neck for the first 3 categories, and time constraints also do seem to be a major issue that people deal with. So from Mars perspective, typically these are the steps that we follow for tendering, and hopefully if we follow these steps properly, the issues that we're having with cost accuracy, with vendor reliability, with scope clarity, as well as with constraints and time can be dealt with effectively. So we start with vendor pre-qualification, wherein you pre-qualify and you look at the right vendors to give the tender to. The right vendor might not always be the best vendor profile that you have received. The vendor needs to be the right size and the right fit for your organization. And I'll go over this a little more in detail. After this, we need to look at preliminary estimate closure, wherein we get an idea of what the project cost estimate needs to be to some degree. Then creation of tender drawings, bill of quantities and conditions in contract. In my opinion, these two steps happen simultaneously, and all three of these are required to go into step E, which is the call of tender to pre-qualified vendors. Clarity in tender drawings, in bill of quantities, and in the conditions of contract enable the pre-qualified vendors to be able to quote properly. And working on step C and D will ensure that majority of the glitches are sorted. However, there are always some niggling questions that exist, which are then addressed in technical normalizations, which is a meeting held with all the vendors to normalize all of them and bring all of them on par technically. Once this is done, the client can be rest assured that technically everyone has understood what is required and they can solely focus on the commercial factors. And then, of course, once the project is awarded, the main work happens from a constructability perspective, which is the execution of project and the closure. So if we execute the first 7 steps well, we ensure that we are giving the best base possible for our project execution to take place successfully. This is the foundation on which our building rests. And I believe firmly that a project is half won or lost at the tendering stage itself. So there are various tendering approaches that are utilized in India. I mean, I've tried to keep myself restricted to the biggest 5 or 6. Each of them have their pros and cons, and I'll try to go over them very quickly and very briefly. So firstly, we have an open competitive item rate BOQ. Then there's the limited or pre-qualified item rate BOQ. There's a lump sum turnkey tender. There's an engineering procurement and construction tender. There's an engineering procurement, construction and management tender. And these are for the bigger sort of project. For smaller projects and minor works, framework or rate-based contracts can also be used. So typically, an open BOQ is, like it suggests, it's an open BOQ. It's an advertisement, and you invite anyone and everyone to compete. So the advantage of this is you get a wide range of prices, and it's very good from a negotiation perspective because someone or the other is going to be quoting very low in an effort to win the project. But because there is no pre-qualification, there is no guarantee on delivery other than a retained EMD or maybe a bank guarantee that you've taken in lieu of advances for cost recovery. A limited tender mitigates that to some extent, wherein you pre-qualify the vendors and you ensure that the tender is only going to 4 or 5 or 6 people. And that way, I mean, in terms of things, the safeguards of that you have within you of a contractor abandoning the project are lessened because you have spent some time in pre-qualification. But you have, by having a limited tender, you have to onboard multiple bidders for each set. You don't get that wide a variety, so your sort of negotiation position gets limited a little. And your BOQ has to be very accurate because any sort of increase in any item becomes the responsibility of you as a designer, not the contractor. So this is where the third sort of tendering criterion comes in, which is the lump sum turnkey tenders. Lump sum bids typically mitigate this. You only look at the final value and you have no bearing or concern to what specific items need to be costed at, what is the sort of market fluctuation that is taking place, and so on and so forth. But because you are only deciding on one figure, which is your lump sum or turnkey amount, contractors tend to overestimate and bid because they know that there are no built-in escalations in place. So this, while advantageous from a convenience perspective, could be disadvantageous from a cost perspective. An EPC and an EPCM bid further increase this convenience because the design, vendor procurement, construction, and in case of EPCM, the management of the construction is all in the bidder's space. But this makes the tendering process more opaque because vendor selection is also in the EPC or EPCM sort of consortium space. So you, for instance, there is a bid, there's a consortium that is doing the design and the construction and everything. You don't have a say in who the designer is going to be. You don't have a say in who the tendering is going to be done to, and so on and so forth. And then if lump sum bids only require, say, you're only giving the civil bid as a lump sum or a PB bid as a lump sum, if you give the entire project as an EPC or an EPCM, one company is taking the responsibility of 6 or 7 companies. And if they are taking responsibilities for 6 or 7 companies, they are going to cost for them as management fees for their escalations and a bunch of other things. So this causes overall costing to also get tacked on. So EPC and EPCM bids tend to be more expensive than lump sum bids, which tend to be more expensive than your item rate bids. And for minor works, say for instance, you need to get some minor floor coatings done. It is easier to meet smaller bidders and fix the rate with them and do it on a rate contract basis. This is especially useful for developers who are doing multiple projects and want to establish a relationship for their smaller sort of contracts. So I'd like to go over 2 examples for the same client for 2 separate projects. One wherein the client's procurement team, so this was example A and example B, are for the same site for the phase 1 and phase 2 for the same project. The project value was in the range of 80 to 90 crore rupees, and the client decided that they wanted to open up the tender to the market and they wanted to take bids from as many people as possible because it made it better for them from a commercial standpoint. The client essentially took bids from whoever they wanted. It went from 25 crore rupees to 1,000 crore rupees, and the rates were all over the place. The project was eventually awarded to the L1 vendor, bidder who had a turnover of 40 crore rupees for a 75 crore rupee project. There was an 8-month delay because the contractor couldn't actually handle the cash flow required for this project. The project was eventually delivered 14 months after schedule because the contractor abandoned the project. Project got stalled. It had to get re-tendered, and it ended up costing the client more than the tendered value. Whereas the same client, when they went for the second bidding, they said, you know what, we don't want this again. We will do pre-qualification. They invited pre-qualification from 12 bidders. They shortlisted 4 people. And what they realized was that the bidder whose turnover is 25 crore rupees, 40 crore rupees, 50 crore rupees, they might be smaller and they might be giving them better rates, but they don't have the financial capability to take up a project of this size and give it at the speed that is required. Similarly, a bidder who's a 1,000 crore rupee vendor or a 1,500 crore rupee vendor might be a bigger and better company and might have done bigger and better projects, but because this project is not big enough for them, they don't pay the necessary attention that is required. Their rates tend to be higher, and then when they are not able to pay the right sort of attention, the project suffers. So which is why I said in the beginning as well, the best bidder might not be the right bidder for you. What you need to do is you need to find the right sized bidder. So for something like what I typically try to use is, if a project is worth X rupees, the turnover of the contractor should be between 3x to 5x, because that way they have the financial capability to take on the project. They have enough incentive to be able to put some money into the project and are not dependent on every paycheck that comes from the client. So even if there's a delay in terms of how the money comes in, maybe 2 days, 3 days, 10 days later, the project doesn't suffer or the timeline doesn't suffer. And at the same time, because this project is a good sized project for them, they have the incentive to do well. So for example B, we actually ended up closing with the bidder who was 1.3% higher than what our estimated rate was, but the project actually finished 10 days before time. And I think that 10-day saving was a lot bigger for our client than the 1.3% extra that they had to pay, which is still less than what they had to pay in comparison to example A anyway. And so this is something I always tell clients or architects or whoever. Our obsession with finding L1 vendors, irrespective of their capabilities, is the leading cause of issues that take place in projects, in my opinion. So I have another poll now, sort of moving into the tendering aspect of things. How many of you still rely on Excel or manual methods for estimation versus using a hybrid of BIM or using a hybrid of other sorts? So if we could have the poll, please. Yeah, the poll is now open, so I'd request all the attendees to vote. Yeah, I think we can close the poll now. So what we are seeing is, I think over half the people, 51% of the audience is using mostly Excel. Around 29% of the audience is using a mix of Excel and BIM and automated tools. 15% of the people are using hand calculations and are mostly manual. And 4% of the crowd is using completely BIM and automated tools, which is quite interesting. It's quite actually interesting to know that over, I'd say, what, 15, 30, 80% of the people are using a combination of Excel and BIM, which is quite an interesting thing. So I'll now go into preliminary estimates. So a preliminary estimate is an area-based estimate, which is giving you the cost for all the key components as blocks. So for instance, you consider the cost of a building, the cost of roads, that sort of thing per square meter. You consider the cost of boundary wall and external drainage per running meter, tanks in kiloliters, earth filling in cubic meters, and that sort of thing. And these are made along with drawings to help a client make informed choices. Now, these numbers, of course, cannot be numbers that are plugged out of thin air. There has to be some logic to them. So what we try to do as architects is to increase the degree of accuracy. Firstly, you take into account the soil investigation, the land survey, the hydrogeological survey. You understand from the class, and these things help us in figuring out what the levels of the building should be, how much cutting and filling is required, what is the strength of the foundation that is going to be used based on the loading that we have. We understand from the client what their staff requirements are and how many shifts they're going to come. What is the office space going to look like? Apart from these are things that I'm saying apart from understanding the flow and scope of the building. What is the floor loading going to be like on the ground floor if they have any mezzanines or first floors? Because things like staff requirements help us not only understand how to seat them, but also how many toilets are needed. What is the STP capacity going to be like? Then what are the utility requirements going to be? How is the boiler going to be fired if there is a boiler that is there? What are the gases that are going to be used? What are the electrical requirements? Are they getting a connection, or are they going to be reliant on diesel generators or natural gas generators? So all these things, when we combine them with our understanding of the industry and doing a survey of the material rates in the region, all these things together help us design a preliminary estimate to some degree of accuracy. Now, for my company, this typically varies from 5 to 10%, depending on our familiarity with the industry and how many projects we have done in this particular sector. But typically, we say that these need to be designed to a plus minus 10% degree of accuracy. Now, for that, there are a number of things that do need to be considered, like I said, and it does require a certain amount of practice. It's not easy for someone to say that, oh, why does this building cost 20,000 rupees a square meter, or 15 or 12 or 25 or whatever it is. There needs to be a justification to the decisions that have been taken by means of the methods that we have used. But once you make a preliminary estimate, like say you've given your client 3 options from an architectural perspective, and you give them the 3 preliminary estimates with the degree of accuracy that has been considered, that helps the client make the decision that, you know, I can go for a slightly better layout if it's only costing 2% more. Or if I go for this particular option, maybe the filling is too much and I don't want to do that much filling. I'll design culverts, or I'll put pumps and sumps and get the water out in case there is flooding. So these sort of things help clients make informed decisions, and these decisions then lead into us making the BOQ and the tender. Then, like I said, upon the finalization of the preliminary estimate, we work on the BOQ and the tender. So it is, like I said, it is important to have all the key information and all the key assumptions made. Any sort of detailed BOQ that we make, whether we're making it on Excel, whether we're making it on BIM, whether we've created a sort of hybrid, or whether we've created an automatic sheet on Excel that we use, all these things are a case of garbage in, garbage out. The more accurate the information that we are privy to, the better the quality of the final cost. Now, the ideal scenario in these cases would be if the client waits for all the detailed drawings to be made and only then starts tendering. And if that is the case, then you can make the BOQ to 100% accuracy and everybody is happy. However, more often than not, that is not the case, because like I said, we're always rushing against the clock and running against the clock. You have to make a lot of assumptions, and you have to make a lot of smart assumptions and smart choices to lend a certain degree of accuracy. So it is important to have all these key assumptions signed off, and it is important to have as much information with you from day one as possible. All the information that I mentioned earlier, if that can be received to a higher degree, then once the client has signed off on things and they have signed off on, say, the column layouts, then it is prudent to ask your structures team to get a preliminary structural design and drawings done. so that you have a basic size of foundations, you have a basic size of columns, beams, other things. If there are any machine foundations that are required, if the client can give us, maybe the sizing of the boiler that they're putting, or the sizing of the machines that need to be put, they require some foundations. That helps in these things. And the more the information we get, the better it is. The goal is to make a BOQ to a plus minus 5% degree of accuracy, and with a discussion with the client, with the buy-in of the client, proper buffers must be put into the place if there is a positive. Like I said, the more the information we have, the better the degree of accuracy. But if there is a lesser information, you tell the client upfront that, you know what, I don't know much about what is going to come. I'm going to design it basis this, but I'm going to keep a 10%, 15% buffer. And that way I safeguard you from having to take more budget or having to sort of make a BOQ that is not future proof. It is very important to have all of this information. And also, it is very, very important to have a full survey done of the vicinity. One can never rely on just having the DSR for the rates. I see this very often with engineers, with contractors, with clients. There is a reliance on the DSR for that region. DSRs are only reviewed once every 3 months, whereas item rates can change on a daily or a weekly basis. They can change based on monsoon. They can change based on season. They can change based on demand. There are so many things that can take place that are so specific to a particular region that can cause rates to go up or down. So it is very important to do a proper survey of the area and do a proper rate analysis for all the key items and submit this to the client along with the BOQ and the baseline assumptions. And lastly, it is versus cost saving while considering for items. Some items might be a little more expensive, but they might save enough time, or they might cause savings in OPEX to justify the slight increase in CAPEX, and one should get a buy-in from a client for this. So for instance, these days for most clients, factory floors are normally concrete floors, and the screed on the concrete floor traditionally has always been done by means of the vacuum dewatering, the sort of trimix rolling machine. But that limits the size of the panel to 6 meters by 4 meters. However, if we go for a truss screed or a laser screed, it is only a little more expensive than this, but the speed of the flooring is 2 to 3 times faster. So you might end up spending maybe like 100 rupees per square meter more, but you end up saving your client anything between 10, 15 to 30, 40 days. And that saving very often is more than justifiable to the client because their factory starts that much quicker. They're able to make so much more money in the time that they have saved, or by means of, say, putting insulation. If you put the insulation, it's a little more intensive from a CAPEX perspective. But from an operational expenditure perspective, you end up spending less money on electricity, you spend less money on air conditioning, and that ends up saving a lot of cost for the client. So these decisions should be taken in conjunction with the client. The goal shouldn't always be to show the client कि मैंने आपके इतने पैसे बचाए. Everything should be taken with a grain of salt, and everything should be taken with a modicum of intelligence. Then, in my opinion, what is equally important to getting the estimation and the BOQ part right is the tender documentation. The tender documentation must be designed in a way that it is future proof, while at the same time it safeguards the client and it is not exploitative of the contractor. So all the conditions shouldn't be always in the favor of the client. You need to understand that the project needs to be done and it needs to be executed by someone on site. So it should be a fair balance, and it should also be very, very future proof. I mean, there are so many things that need to be considered, but I think the key parameters are understanding the payment terms, understanding the project timelines, understanding from the client that this is when my machine is going to come, this is when the machine will get installed, this is when the utilities will get installed, this is when the connections will take place, this is when my trial production will start. And these decisions then inform the schedule. What are the compliance requirements? What are the advances that they are willing to pay? If it's a brownfield project, what are the working procedures that need to be followed? Are there timelines that need to be considered? Any basic rates of materials? Will water or electricity will be provided? What are the penalties? Can a labor camp be put? What are arbitration requirements? How will material escalation clauses take place beyond a certain point of time? What are the approved list of makes? Anything that can affect the outcome of a project must be used and covered in the tender document. And once a tender is called, it is imperative to have a technical normalization meeting with the vendor, keeping into account all these conditions that we have considered. Technical normalizations, you discuss with the contractor how are you going to execute the project, what is the labor deployment, what is the machine deployment, what is their understanding of the tender, what are the tender conditions, what are the rates that they have quoted that are too high or too low, and all these things together ensure that your contractor has the right information when they are quoting for the project. I mean, I'll give you a few examples. There was one case where a contractor did not read that dewatering is in their scope. It was a part of our tender conditions given loud and clear. They had to dig a basement, and basement excavation happened. We found, I think monsoons hit that region uncharacteristically early. I think they hit them about a month and a half early, and the entire basement got flooded, and the contractor refused to dewater. Had we not put that in the conditions, we would have had to pay a lot of money to the contractor to get that dewatered. And because the contractor did not read the conditions of contract properly, they actually ended up spending a lot of money out of pocket to get this done. Again, technical normalizations, we've seen very often, contractors have misunderstood items, they have misunderstood scopes, and they have given rates that are incorrect. There are rates with aberrations. There are so many problems that take place. But the most dangerous case that I have seen in technical normalizations when you're speaking to a contractor or a prospective bidder is when they say yes to everything. हाँ जी कर लेंगे, हाँ हाँ हो जाएगा, बिल्कुल सही, हाँ हाँ हमने यही कंसिडर किया है. When they have no questions, when they agree to everything that you're saying, chances are they have not read your bid document and have just quoted. So ensure that when you're sitting with a contractor or a bidder, when you're having the technical normalization with them, you are understanding not only what they are saying, but what they are not saying, and what all is sort of hidden between the lines. Because these things, when they don't happen, they do end up creating problems. Then, sort of harkening back to the poll that we had, like I said, if the time permits, it's always better for us to have all our drawings ready before tendering, as this ensures that the cost we receive is 100% accurate when there are no deviations. But because the integration of BIM and GFCs takes time, and there are a lot of changes that take place during execution, it is important for us to have a good middle ground using both technology and traditional calculation methods. For instance, when you have the column spacing that is there, you get the worst column design, or you get the worst foundation, the heaviest foundation design, and use that to make a bar binding schedule and use the steel and cement and other things accurately instead of using just thumb rules for calculation of steel. Then if the time permits, of course, it's better to use things like BIM 5D and account for design, cost, schedules, and other things. However, it is important when that is not possible for us as architects to forecast scenarios where there can be delays that we have seen historically. For instance, when construction happens, we know for a fact that during Diwali and Chhat Puja, labor is going to leave. During Eid, labor is going to leave. During Holi, labor is going to leave. These days, with the way the pollution is, there are going to be bans that are going to happen due to NGT. So all these things need to be accounted for in the schedule. With the heat, with the sort of temperature that we have, 45, 46 degrees, it is inhumane for people to work at long hours at a stretch. So productivity will go down. All these things, when they're accounted for, they help us make realistic schedule. Not just this, from a costing perspective as well, using historical data and using the data that we have to forecast when costs of certain materials will be high or low is again very, very helpful in my opinion. For instance, with soil, you know that when monsoon is going to happen, soil, bricks, other things, costs are going to go up. So if you buy the soil, if you buy the bricks, if you buy things, you stack them, you keep them. When they are required, you can use them. With cement and steel, during monsoon, the demand goes down. Then come Diwali and other things, house construction is happening, so demand goes up again. So using historical data to create a chart to forecast when costs are going to go up and down, and using it to actually buy material can end up saving cost. It is always best to shift from a reactive estimation to a predictive estimation base that is happening. And this is something that is happening globally. And we as India must look to catch up and then work towards becoming market. And lastly, in my opinion, from a tendering perspective, using digital portals and reverse auction signs, once all the normalizations are done technically and everyone is on par, the only thing that is paramount is cost. So using digital tendering portals, And using reverse auction sites, it assists with transparency and with speed, and it helps us getting the lowest cost. Lastly, I feel that it is important for us to estimate for the non-shed aspects of a factory as well as much as it is important for us to make the factory shed important. Value engineering for roads, for drainage, for utilities, for worker facility blocks can make or break project costs. Do we always need, a thick RCC road, or can we get away with bituminous roads in some places? Do we always need, say, concrete pipes, or can plastic pipes be used in certain places? These are some things that need to be considered. Also, furthermore, when you account for future expansions in master planning and future proofing the building, you are able to ensure that when the next phase comes, the previous phase sees little to no disruption. This saves a lot of time, rework, and money. So something that we do with our clients is we make a master plan for first phase, second phase, third phase, everything that is coming up, and say the next building needs to be joined with the previous building. We account for that in the foundation itself. That side's wall is designed in a way that it can be easily removed. The same provisions are taken in the utility block, and nothing is placed where the factory needs to be designed. These things, these sort of decisions as civil engineers, it is very important for us to consider from a scheduling perspective, from a design perspective, from a tendering perspective. And lastly, ESG requirements. If you use proper waste management techniques, solar panels, low flow fixtures, paints with high solar reflectivity index, proper insulation, rainwater harvesting, along with timely permissions, these help save a lot of money from an OPEX perspective by being a little more expensive in a CAPEX perspective. So over a 2 to 3 year period, your client saves money. And also what does happen is if you take all these ESG requirements in place from D1, it is very easy to get factory inspector approval and other approvals. So what I always tell people is when you're designing a factory, think of the next 20 years, not just the next 2 years. So for us, we at MR Warerkar, we do end-to-end design. We do architecture, structures, civil, plumbing in-house, and we have electrical, HVAC, firefighting. We have consultants who we work with. We can't recount the number of times where reworks have had to be made because someone is working on revision 4 of the drawing, someone is working on revision 3 of the drawing, someone is working on revision 1 of the drawing. From a civil planning perspective, the most important thing is integration and free flow of information, and everyone is on the same page when working. So to prevent this, it is very important to make coordination drawings for all the disciplines. You either do it in 2D or in BIM. You define a clear scope. You make RACI matrices which are responsibility, accountability, informed, and characteristics. So everyone has their own sort of role in this. All of these things, when you have coordination drawings, when everyone is working on the same version, and if everyone knows their role, it prevents a lot of rework, and you minimize a lot of errors, and you save a lot of cost and time. So now I come to the third and last poll that I have. So where, having heard all of this after the presentation, do you see the maximum potential for improvement in your project? The poll is live now. I think we're running a little over time. I'll very quickly go through the case studies that I have after this, and we can then go over some questions that you as audience may have. I think we can shut the poll now. I think what I have seen is, again, it seems to be quite a mix. I think 36% of people see maximum potential for improvement in civil planning, 25 and 23% see in coordination and tendering, and 16% see potential for improvement in estimation. So it's quite an even split. So I'll come back to the first project that I showed all of you. So I'm sure you can see this long building over here, which has curved roofs. So this is essentially from the first building that you can see over here, where my cursor is, the building in front of the building to the left of this building, all the way up to the big building with this tall sort of minaret, not a minaret, but like this tall RCC structure coming out. This entire plot belonged to my client, and this was the only building that existed. This was a textile factory that they operated, and they moved the textile plant away and they started food construction. They wanted to start food construction over here, namely biscuit manufacturing. And so the idea for them was to demolish the entire building and remake an entire building, because they had Proflex roofs, and you can't hang utilities from Proflex roofs was the, I mean, and it is still very, very difficult to hang utilities from a Proflex roof. So we at MR Warerkar, we, of course, we never want to see a client spend more money than they need to. So we, our structures team, our MEP team, our architecture team, our civil team, everyone worked together, and we found a way using supporting structures. And at that time, gripple, which is the wires that are used to hold things in place, that was a very new product. So using those, creating supporting structures, and with minor rework, we were able to retain the existing building and having to demolish the entire building and reconstruct, which saved the client an estimated 80 to 85 crore rupees. Furthermore, as you can see, this building's at a different level, this building's at a different level, different level, different level. These are more or less same, but this is a little higher than this, different level, different level. So this plot essentially is a 26-meter gradient plot going up and down, and this entire plot is rock. So if you cut, you spend money. If you fill, you spend money. So by means of plotting the plot on Revit, by means of actually working out the optimal cut and fill, and by taking the warehouses away from the building and using conveyor belts to ship, to take the products to the warehouse, we were able to save the client a little over 10 crore rupees in cutting and filling. And we've done a number of other things, big and small, in this project. And when we sat down with the client and the audit team, we realized we've saved them over 135 crore rupees in this project over the 6 or 7 phases that we have worked. And however, I mean, while it sounds very good, not everything went to plan. I mean, we did have some goof ups that did take place. So for instance, there was an increase in the silo load over here from 1 ton per square meter to 2 ton per square meter. And this happened after the foundations were made. So there was a lot of change in the design. There was some demolition, and there was a lot of rework that had to be done. Work happened during COVID. Cement and steel prices escalated beyond belief. And because there was no basic rate clause for cement and steel at the time, the contractor bore 50% of the cost increase. There were change in mining laws that caused aggregate and sand costs to go up. There are a number of things that actually went wrong during this project as well. I mean, of course, not everything is going to go 100% right, but these things taught us, I mean, to keep clauses for major items like cement and steel, to keep basic rates so that if costs escalate, both the client and the contractor are safeguarded. And yeah, so I mean, yeah, that's pretty much about it for this project. Then, like I'd mentioned, this was a first of its kind project in India. Here, what was very important for us was vendor pre-qualification, because something like this hadn't been made earlier. It was very important to get a buy-in from the contractors, to get a buy-in from the PEB contractors to understand that they will actually be able to manufacture this building. And because everything rested on PEB, with like right from getting the building ready on time to following the international guidelines that were given to using star columns that were encased to ensure that all the so that the building is completely dust free, everything rested on finding the right PEB vendor. And this is something that we were able to do, and it helped. One more thing over here was the client insisted, according to their old guidelines, that they wanted to go for trimix flooring. And that is something, because that is something that they had been using for the last 20-25 years. We convinced them to go for laser screed flooring, and this ended up saving them a lot of time. Then this is a facility. This, as you can see, it's got quite a funky shape. There's a lot of cutouts and other things over here. So this wasn't by design. We weren't trying to make it an architectural feature. There was a high tension cable that was running close to the plot, and because of this, you couldn't construct anything 36 meters on either side. So while mapping for that distance, while also trying to maximize the amount of floor space that we can cover, we ended up getting this very funky design over here. And not only were we able to deliver on all the requirements that the client had, but they actually did end up liking the facade quite a bit. Lastly, this is a project we did in Zimbabwe. So our head of civil engineering, Mr. Zakir, he actually went to Zimbabwe. He sat with the client. He went to market. He understood all the rates that are required as per local requirements. And after understanding the local market, he tweaked the tender and the BOQ that is made in India and customized it according to how it needs to be made in Zimbabwe. Not just that, we worked with the client on pre-qualifying the right vendors, because there were no vendors that existed in Zimbabwe. So finding vendors in Europe, finding vendors in China, and also for the PEB that had to be done. We looked at three options: shipping the material from India, shipping the material from China, and shipping the material from a local plant in Africa. Pre-qualifying all the vendors who can do all of this, looking at their cost, looking at their time commitments, and then figuring out what is the best method and procedure to do this. So at times it's about, the best way to do things is just going to market and gritting it through and doing a lot of hard work. And that is something that we ended up doing a lot of in this particular project. And that's it from my side. Thank you very much. So if there are any questions, I'm happy to take them.
Thank you, Siddhant. There are a few questions. I will take them. Okay, so the first question is can civil strategy reduce life cycle cost, not just capex?
Yeah, so absolutely. The way I sort of see it is through doing proper analyses and having a good understanding of the material, we can, and of the building sort of thing in general, we can do several things that can save the life cycle cost of a project. So for instance, if we use insulation and if we use a paint with high solar reflectivity index, we are decreasing the heat load and we are decreasing the requirement for HVAC, for fans, for AC. So this saves electrical cost and this saves AC cost. If we look at, say, the 100-year flood data of a particular project, we spend a little more money doing the hydrogeological survey, but you can optimize the amount of filling that needs to be done in a plot to ensure that the plot doesn't get flooded. So there are a number of things that can be done as a part of civil strategy by understanding materials, understanding each material's pros and cons, and seeing where spending a little more money in capex can save overall money in opex.
Okay, there is this question, how can architects convince clients to adopt realistic estimates? Furthermore, how do we convince clients not to just go for the lowest bidder?
So again, this is actually quite tricky because there's only a certain limit till which you can talk to a client and try and convince them that, this is the right way to go, and maybe the L1 vendor is not the best vendor. But the way I try to talk to clients is, see, there is a triangle for cost, time, and quality. I ask the client to put a pin where they want the things to be from a balance perspective. If the pin is put on cost completely, the timelines and quality go for a toss. It is always best to have a balance of cost, time, and quality. So even though a bidder who might not be the L1 bidder might be given the project, they will end up saving you time by being able to put more labor, by being able to put more people. They'll be able to actually execute the project on time, but also give you good quality, thereby reducing rework. So say, the project is worth 10 crore rupees and the bidder, the L1 bidder is quoted 10 crore rupees and another bidder is maybe quoted 10 crore 50 lakh. You're spending 50 lakh rupees extra, but he's giving you the project with good quality 1 month in advance. By getting that project 1 month in advance, the client might be able to earn 2 crore rupees more. So it's about that justification, giving that rationale to look at the bigger picture rather than looking at that this individual cost is just a site.
Okay, how do you deal with volatile material prices, especially for steel and cement?
Again, steel and cement there were huge sort of increases in cement and steel during COVID, then again during the sort of Ukraine war that happened. After that, cement and steel has tended to stabilize a little, but there are fluctuations that do take place in the market. So the way we deal with it is we look at it from a historical perspective. Unless there is a force majeure thing that happens like COVID, we look at the seasonality of the thing. We know when there are going to be spikes in construction, when there are going to be dips in construction. And what we also do is we try to talk to RMC vendors, like the ready mix concrete vendors. We try to talk to reinforcement steel vendors. We try to talk to PEB manufacturers. We try to talk to people who are experts in the field and try and take forecasts from them for the next 3 months, 6 months. Okay, do you think it's going to go up? Do you think it's going to go down? What are the policies looking like? And so based on these things, as well as based on the historical data, we try and track how the volatility in market is going to change.
Sir, there is this question: the tendering steps mentioned by you are the same which is practiced in all the projects. So what is something which you do differently?
From a tendering perspective, what is it that we do differently compared to the steps that I've shown in the market? For that, you'll have to hire me, right? No, what we try to do differently is we try to make tenders, firstly, that are future proof, wherein we account for all the details. We don't just stick the CPWD guidelines and say that this is the tender. We look at each site individually as a living, breathing organism, whether it's a greenfield project or a brownfield project. What are the individual requirements that a client has, how they want their project to be executed, and we use the client's input and data to actually change the way the tender is structured. So I mean, just to give you an example, I have two clients who are working in an identical sort of industry. Both manufacture biscuits. One of them makes premium biscuits. So for them, their focus is not always the time. So they actually give, they're quite free with time. But if there are quality related issues, they penalize them for that. Whereas I have another client who makes low cost biscuits. So for them, the penalties are actually dependent on the time, not as much on quality infractions. So we sit with the client, we discuss with them, and then we sort of change and tweak the way the tender is designed.
Thank you, sir. It was a very inspiring session. Thank you for taking us on a journey beyond the conventional lens and showing us how tendering, estimation, and strategy from the invisible framework of industrial excellence. To all our participants, conversation like these reminds us that the future of construction and design is not built in silos, but in the exchange of ideas, insights, and inspiration. We hope today's dialogue leaves you with new perspectives and renewed energy to create, innovate, and lead. Do join us for the next chapter of Smarter Conversations. We continue to bring you voices and visions that shape the future of engineering, design, and construction. Until then, stay inspired, keep innovating, and let's keep building smarter together. Thank you, sir.
Thank you so much. Thank you for having me, and all the best for the rest of the webinars that you do have.
Thank you. Thank you, sir.